How did Earth warm enough to support life? New research suggests that the answer lies in a perfect coupling between the qualities of a star and a planet. Today, Earth stays warm because carbon dioxide in the atmosphere holds in reflected heat from the sun. But 4 billion years ago, the Earth received less warmth because the sun was a young star and produced less heat. Recent models of our young star show it was much more violent than it is now, constantly erupting and sending out huge particle clouds. Young Earth was different too. It was still growing its magnetosphere, the magnetic shield that protects planets from the sun's forces. This weaker magnetosphere's polar caps were far wider than they are now. This let particles from the active sun seep into Earth's nitrogen-rich atmosphere. The solar particles split up the nitrogen molecules into atoms, and carbon dioxide in the atmosphere into oxygen and carbon atoms. The free-roaming oxygen paired with the nitrogen. The result was nitrous oxide, a powerful greenhouse gas. Despite the weak contribution from the sun, the planet was able to warm enough to brew and incubate life.